If there's a trolley, initially let it be at rest, and we have let the trolley accelerate, then we'll see the conditions. So initially the bob, the trolley is at rest, and the bob will oscillate. What about the oscillation? What is the state of trolley? Trolley is at rest. Now let it get accelerated. So when it get accelerated, what is the time period? When it is at rest, what is the time period? Then when it is at rest, what is the time period of the bob? Is given by 2 pi under root of L by G. When it gets accelerated, you should get the mean position. Now the mean position will be this one. No? This is the mean position. Okay, now this is not the mean position. This is not mean position. It will oscillate about this particular point. Then I'm just going for some. This will be pseudo force MA. In the person sitting in the trolley will do this problem now. This mg will act, and the string will be tension in the string at equilibrium. And we know the string will make an angle theta. Then we have a formula T equal to 2 pi L by G. This I will ask you to rewrite. Already we have written, no? This. Can I adjust ML? Here what will happen? I'll go for G effective. So instead of this, let me write T. G effective. M G effective should be written. This is some generalized formula I'm trying to arrive. Mg effective, or this will become ml by tension in the string at equilibrium position. Otherwise, what we should do, we should displace this bob from this position, then we should calculate the torque due to ma and mg. This would be a very lengthier approach. We have just converted this into some sort of like a formula. If the point of suspension accelerates, bring G effective. Or this other alternative approach which we should have. Okay, now can we calculate tension in the string at equilibrium? This will be much easier. Te sine theta squaring and adding is equal to m. So what is the tension in the string at equilibrium? So what is this Te? Tension in the string at equilibrium. This will calculate in the time period. What is the formula? ml by Te. What is the tension in the string at equilibrium? G square plus A square. The point of suspension accelerates, we do write in this way. Okay. You know how to calculate with a pseudo force what is the string makes an angle theta, and you know how to calculate tension in the string at equilibrium. Then directly substitute here, or else you know how to interact with the G effective, how to calculate the G effective, substitute G effective here. Either way, so I do prefer to use this particular method because this is what advisable. We are very good in laws of motion, so we can take help of that particular knowledge here and we'll find out the tension in the string at equilibrium or at mean position. Tension in the string at equilibrium or mean position. mean position with bob at rest. This is the condition, not when oscillating. When oscillating again, Te minus, it will have m omega square r. Okay, agreed. Okay, now we'll take some other different cases. Suppose that there's a pendulum. It's in equilibrium under action of forces, where F1, F2 are some external forces, and the action of this is in equilibrium. Now I am asking you to calculate the time period of oscillation. So it's going to oscillate like this. It will swing here, here. These forces will be continuously acting vertically up. So what are F1, F2? F1, F2 are external forces acting on the bob in the shown direction at all times. Find time period of oscillations of the bob. How do we manage this? Hope everyone getting some picture, no? Some idea. This is what like it will make some angle theta. Theta, let me just define it here. So again, we should calculate the tension of the string at equilibrium. There will be some tension where the string makes an angle, certain angle with vertical at equilibrium position under action of these forces. So what we should do, just calculate the tension of the string at equilibrium and substitute in that formula. So we'll proceed in this way. Te Te cos theta plus F2 minus Mg0. Te sin theta minus Fn 0. Squaring and adding, T is equal to then time period of oscillations is given by ml by Te. This will be more easiest approach than any other thing. Okay. What is this? This particular position is equilibrium position. Bob is in Hope everyone getting some picture. Accelerating or this, we can use this particular following method. Let's take the